In this video, we're going to take a look at exam revision for quadratic inequalities. So what we're going to do here is just take a look at a number of different exam style questions for quadratic inequalities. So let's get started here with question 1. We're asked to solve x squared plus 9x plus 20 is less than or equal to 0. So remember, to begin with here, we start by factorizing this quadratic. So if I factorize this quadratic here, what would I get? Well, I'd simply get x plus 4 and x plus 5. This is less than or equal to 0. So from here, I now identify the critical values. So one critical value here is x equals minus 4. We have a critical value here is x equals minus 5. Now once we have the critical values, don't forget we draw a sketch here. If I quickly draw a sketch, that's my y-axis. Draw my x-axis here as well, like so. So minus 4 and minus 5, so if I just extend the negative part here, the x-axis a little bit. So if I say this here is minus 5, and this here is minus 4, what we'll get is something that looks like this. Okay, like so. Now, we're looking for this quadratic here being less than or equal to 0. So in other words, where is this below the x-axis? So we do this in a different color here just to highlight this. Below the x-axis then will be between here. So then presenting the solution here now as an inequality, what we get is x being between minus 5 and minus 4. And notice for my solution here, the inequality symbol should match what we started with. So if it's including the equals here, we need to include that as well for our final solution. Okay, well there we have it. So that gives the solution there to question 1. Moving on to question 2 now, we're asked to solve x squared minus 8x plus 15 is greater than 0. So as always, we start by factorizing this quadratic here. If I factorize this quadratic here, I'm going to get x minus 3 and x minus 5. And this is strictly greater than 0. So from here then, we need to identify the critical values. We're going to get x equals positive 3. We're going to get x equals positive 5. So now that we have the critical values here, we need to draw a sketch of this quadratic. So quickly drawing a sketch here. That's my y-axis. This is my x-axis here. So our critical values then are x equals 3 and x equals 5. Let's say that's 3 there, and this is 5. I'm going to get something that looks like this. Okay, so now we're looking at this quadratic here being greater than 0. So in other words, where is this above the x-axis? So again, let's do this in a different pen color. Let's do it in red this time. So that would be everything to the left here of 3, like so, and everything to the right of 5. Okay, so how do we present our solution here? I'll present this then as 2 regions. So I've got x being less than 3. So therefore, x is less than 3. We also have x being strictly greater than 5. Okay. And there we have it. So that's the solution there to question 2. Moving on to question 3 now, we're asked to solve x squared minus 4x minus 5 is less than x plus 1. So where do we begin here? Well, what I need to do is take one of the sides here of this quadratic inequality, so either the left-hand side or the right-hand side, and set that to 0. So in this case, the right-hand side here is easier to work with. So what I'm going to do here is make this right-hand side 0. So what I need to do is get rid of the x and the 1. So I've got x squared minus 4x minus 5 is less than x plus 1. Okay. So like we said, we need to get rid of the x and the 1 here. So you can do this all in one step, but if not, it might be easier to do this step by step. The first thing I'm going to do here is get rid of the x. So to do that, I'm going to subtract x off both sides. Let's subtract x off both sides here. We minus x off both sides. In that case then, what I'm going to get here is x squared minus 4x minus x. That would give me minus 5x. We've got minus 5, and that is less than 1. Okay, because x minus x would give me just that 1 there. They'd cancel. I get simply left with 1 there on the right-hand side. And then finally, what I'm going to do now is subtract 1 of both sides. So minus 1 and minus 1. And like I said, you could do all of this in one step if you find that easier. But just doing it step by step so you can see clearly how we got from this line here to our final line. So I've now got x squared minus 5x. Then we've got minus 5 minus 1, so that would give me minus 6 there. And that would be less than 0 because 1 minus 1 gives us 0. So from here now we have a straightforward quadratic inequality. So remember we start now by factorising here. We're going to get double brackets here. So what would we get in this case? Well, I'm going to get x minus 6 in one of the brackets and x plus 1 there. That will be strictly less than 0. Okay. So from here now we need to identify the critical values. So one critical value here is positive 6. My other critical value is x equals minus 1. Once we have the critical values, don't forget we do need a sketch. So I'll quickly sketch this here. As always, it doesn't need to be perfect. It's my y-axis. This is my x-axis here. So minus 1, let's say that's there, and positive 6, and we'll say that's there. So if I sketch my quadratic here, we're going to get something that looks, say, like this. Okay. So we've got our quadratic now, our diagram, our sketch. So what we need to do now is identify the solution here. And we'll do that in a different color. Let's do it in orange. So where are we now below the x-axis? So because it's less than 0, this is below the x-axis. So in this case then, that would be this region here. And for that region then, that is going to be strictly between minus 1 and 6. So in our solution then, like we said, that would be minus 1 and 6. Okay. And there we have it. So that is the solution there to question 3. And finally, we take a look now at the very last question here, where we're asked to solve 2x squared plus 9x plus 4 is greater than or equal to 0. So as always, what we do here is we start by factorising. I'm going to get double brackets here. This will all be greater than or equal to 0. So at the front of one of these brackets here, we're simply going to get a 2x. And at the front of the other bracket, we're going to get an x. Okay. So two numbers here that will times give me 4. Again, you can do this using trial and error, inspection, or another method that you're familiar with. But what you should get here for the factorized form is 2x plus 1 and x plus 4. Okay. So from here, once we have the factorized form, we now need to identify the critical values. So from this first bracket here, we're going to get x equals minus a half. Don't forget, all we do here is we set 2x plus 1 equal to 0. Subtract 1 off both sides, so 2x equal to minus 1, and divide both sides by 2. So I get x equals minus a half there. And for my final bracket here, x is equal to minus 4. Okay. So we now have the critical values. We now need to do a sketch of this quadratic. So if I do a sketch here, what would we get? That's my y-axis. This is my x-axis here. Let me just extend the negative part here a little bit. So we have minus 4 and minus a half there for the critical values. So I've got minus 4, let's say that's there, and minus a half, let's say that's there. So putting all that together then, what we're going to get is something that looks, say, like this. Okay, that's minus a half there. So in this case then, we now need to use our diagram here to solve this quadratic inequality. So we'll do this in a different color then. Again, let's do this in orange. We're now looking for where we are above the x-axis. So because it's greater than or equal to 0, we're looking for above the x-axis. So we now have two regions here. We have everything to the right of minus a half, like so, and everything to the left of minus 4 there. Okay, so how do we present this solution then? Well, in this case, what we're going to get here is x is less than or equal to minus 4. So we want values smaller or equal to minus 4. So for example, minus 5, minus 6, minus 7, and so on. So those values are getting smaller. We need x being less than or equal to minus 4. And then finally, we have x being greater than or equal to minus a half. Okay, and there we have it. So that gives the solution there to the very last question, question 4. And that brings us to the end of this video on exam revision, quadratic inequalities.